Hello, my name is Brandon Jones again, and I'm here for my second week of my ETM class for mobile gaming in Full Sail. Alright, so I'm going to start up the game. Here it goes. Okay, so actually I'm going to close this down and maximize it on play. There we go. Okay, so here we go. The game is simple. It's sort of like an obstacle course. I'm using Unity's basic character collider, as well as a few more of my other things. Okay, so the goal is to get to that big blue capsule over there. So we go through, and first we had the red block, just showing that off. Next we have the purple capsules that just pop out of the ground, so you have to get by them. You kind of have to remember where they are. So red, go through, and then finally we get to the end, and you win. It shows you how long it took to complete the course. It tells you one if you win, and it goes back to the main menu. Sorry, once again displaying the main menu. Super simple. Just shows the title and has a play button. So we do play, it's WASD to move, so we go through. If you die, so if you take damage, this collision, and you lose a life and go back to the start. So go here, get hit again, and then finally the purple thing hits you and you die. Okay, so if you lose, you don't get your time, it just says you lost and it goes to the main menu. Okay, so that's the game itself. So I have in my main menu scene, we'll load that one up first. Main menu. All I have in the main menu scene is just a simple main menu actor object which holds the main menu logic. Okay, so opening up mono development, and we have the main menu object. Main menu logic is essentially we just have the main menu area for our main, or for the menu, which is the entirety of the screen. So it starts at 0, 0, top left corner, and and then it goes for the width and height of the screen all the way. So we come down here, and it's a simple you begin area with the window. Flexible space is a keyword that if you have a label that's over here and you have flexible space before it, it'll say that it can go anywhere within this space, and by putting flexible space on the other side as well, that centers it. It'll draw in the center because it can move anywhere within this freely, so to the left and the right of it. So it kind of just aligns itself based on what the flexible space is. So we have Super Game, which drew right here about mid-screen, because we have flexible space on the top, the bottom, the left, and the right, so it goes about center. And then under that, it draws the button. So if you press the button, it will load the main game scene with application load level. So we're loading the main level, going to scene main game. Main game has the plane for what you're standing on, the goal, which is that blue capsule over here. It has a main camera, which is, if we go back, main camera's up here, and we have a point light above the game so that everything is lit and not completely dark. Okay, so as far as the actual code behind it, once again, oops, sorry, I am using the Unity space third-person camera controller and third-person controller, or third-person camera and third-person controller for the basic movement and animation of that guy you see. I've created my own script called player control, which let's jump into that now. I'm gonna develop. First we have the main game logic, which is attached to the main game object here, which has the player template, the cube obstacle and the cellar obstacle kind of dragged into it, which you can see right, main game object, right here. they're filled in by just dragging them in rather than finding them somewhere. So I have my prefabs there. So we have basic stuff. If the game is running, if you've won, the window area once again. I'm setting up my player. I'm instantiating based on that template, and I am rotating it 90 degrees so it faces the forward. So it faces forward when you spawn in rather than to the left or the right, or backwards for that matter. Spawning it at 16, just a hard-coded value of where I wanted the player to spawn. If this were a full scale, I'd probably have a spawn object that I'd spawn onto. Okay, so we have the cube objects, which is this whole block right here, being spawned in various locations. We have the cylinder objects also in various locations with some randomness so that it's not the same every time. And then we're setting the start time of the game right here. And that's that timer you see. If the game is running, we had the player lives up in the top being displayed as well as the current time you have. If the game isn't running, we have the you won if you won, and you lost if you lost, as well as the time if you won. And then we're loading the level if you press that button that's there. We're loading the main menu back up. So we have player controller, which is simply has lives as a start translation. We have here, if the player falls off of the map, which I didn't show, he will also die. I can demonstrate that really quickly. If I run off the map and fall, then I die and be respawned. Okay, so closing that out, you see the time and the player lives. We have the actual kill player function, which subtracts the lives. Lives are greater than 0, reset the transform. Otherwise, to set the in-game function of the main game logic right here, which sets game to whether you won or lost, sets the game running to false, and sets what time you ended on. For use when you in the game, it can tell you your final score, and then it destroys the player object. When you collide with something, which is the uncontrolled collider hit, we check the other's game tag. If it's an obstacle, so right here we have the prefabs for the cylinder and cube, they're both tagged as obstacles right here. So if they are obstacles, then we will call a function to handle collision, which I'll get into later. And if they're the finish, which is the goal, then we'll set in-game to true and destroy the game, the player object again. So, as you can see, the goal, the blue capsule right here, is also set to finish. Okay, so the base obstacle, all it really has, it's the parent class of all obstacles. It just has this parent base obstacle class. It just has the handle collision function, which all it does is gets the player and kills it, which honestly could have been just simply done within the player class, but I wasn't sure by the time I made this function whether or not I was going to do different things based on if it's hit by an obstacle or if you were killed by falling off the map, per se. So I wasn't sure exactly, so I made it a little bit more dynamic. So we have our two obstacles. I'll start off with the cube. It's a little bit more basic. The cube starts off, it has it sleeping and set to true time. Okay, so if the thing is sleeping, so if it gets to the end of its track, it sleeps for a certain amount of time, which is a base amount, which is 1, plus a random range between 0 and its base duration. So it could potentially double, it could potentially be exactly its base duration. So it could be double the amount of time or anywhere in between that. So if it's not, it sleeps and it doesn't move at all, and then it randomly wakes up again and starts moving. At first I played around with having different move speeds, but I felt like that was a bit too unpredictable for the player, and it's kind of frustrating when you die by something that is randomly faster. So I just had them sleep at random durations and then come back. So it's a little bit more difficult than just running on a flat. You know exactly when they're coming. Alright, so you're translating them normally based on time, and then we have, once they've hit the end of their track, they're set to sleep again. Cylinder is similar, except it moves upwards on the Y rather than the Z axis. So it pops up rather than goes side to side. And as far as the code goes, that's about it. The Unity I had been familiar with in the past, so it wasn't as difficult or as fulfilling, I guess, as the sprite kit. And as a result, I may have procrastinated a bit on doing the work for this Unity project. I probably should have taken advantage of this and done some of the framework requirements as well, such as multiplayer or something. But that was a personal error on my fault with other things. As far as the workload itself, I didn't feel like it was too intense. I felt like it was pretty similar. It probably would have been pretty similar to last week's had I not already had a pretty decent background within Unity. Once again, I think that this was a pretty good project. I don't have any complaints. I like Unity a lot. I think it's really helpful. It's an awesome tool. It's got a lot of awesome background stuff that it does. And that's about it. Thank you very much, and have a good day.